Welcome back to Educator.com, Introduction to C++. Today is our second part discussing functions. We're going to talk about types of parameters, the kinds of parameters that you can pass in. We have call by value, call by reference, call by address. There are default parameters available. And we'll mention again about getting a single return value unless you use one of these call by reference parameters, and how to overload functions, and a brief discussion on how functions are better when you make them small and isolated. We're trying to make it as independent of your application as possible. The parameters by value is your arguments go into the function and they don't come out. I don't want to give the joke about the Roach Hotel because that's not nice. But the function, by virtue of the fact that it does not come back out, the function might change the values that come in. So basically what will happen is it will make a copy of the values of the arguments that get passed in. And this is safer from the perspective of increasing your modularity, increasing your independence from the rest of the code. So here's a quick example. We're going to do multiply by add. Rather than using the asterisk, we're just going to say, well, 3 times 7 is 7 added 3 times. So we're going to pass in a 3, we'll pass in a 7, and we will loop through here 3 times, starting at 0 and ending before we hit 3. So 0, 1, 2. And we will add second to itself. So you'll have 7 plus 7 is 7. That'll be 14. Second time, 7 will be added to that again, and it'll be 21. And this code is actually broken. It will give me the wrong answer. If you add 7 one more time, you'll get 28, which is 4 times 7. So there's another homework assignment, is to fix this code so that it works correctly. But the point being, now it returns the calculated value. Now this parameter is what was passed in. And the function, since it's called by value, the function is free to change the value of this variable as much as it wants, as much as it needs to. There's no fear that you mess up the calling program any kind of way. Your next way is call by reference. Now when you have a call by reference, you include the ampersand between the type and the name of the parameter. So now in this case, if the function changes the value of this parameter, it's reflected in the caller's value. This is a way of getting more than one variable output sent back to the caller, because you can put as many of these on your parameter list as necessary. Now, one restriction, of course, is you have to send it a variable. You can't send it the return from a function. You can't send it a literal value, because how can you take a literal value and then change it? You can't. It's a constant. So it's useful for returning more than one value. Give a quick example here. You have f int a. So now you can change a. Now, you cannot call it with 5. How can you change 5? But if you have a equals 5 and then call it with a, that's fine, because now we have an actual variable whose value can be changed. And here we have an example. We've got a change to our functions from before. We have a function calculate total area, which has variables passed in by value. All it does is multiply width by depth and returns that. Now we have here calculate useful area. We have not only the width, the depth, and the easement. There's a couple of things that we want to pass back to the caller. We want to pass back the total area, and we want to take a calculation of the percentage that the easement is. If it's 1 foot, that's 1% of 100 foot. If it's 50% of your lot. So this returns to the caller some value of how much easement is there. So what we have here, a total, very simple. We're calling this function to get the total. The percentage is the easement divided by the depth times 100, which makes it into a percentage. And returning the width times depth minus easement, which was the original calculation before we added these 2 extra parameters. And here's an example of an error, because 17 and 10 have to be variables. You have to call this with, let's say these are floats. So we'll have float T for total, and we'll have a float EP for easement percent. So now we can call this, instead of setting 17, we'll pass it T. Instead of 10.0, we'll pass it EP. It will do its calculations as before and return back to the caller a value for T and a value for EP, which it can then print out. Okay, this is the total area, and this is the percentage used by the easement. Now, another type of parameter is a default parameter. This is where a caller doesn't need to provide a particular argument. The function says, well, if you don't give me a value for this parameter, I'll use a default. So the function uses default when the argument is not provided. Now, one thing to be careful of, if you send it more than one, if you put 1 in the middle, then everyone after that has to have a default, because the compiler has no way of knowing that this is supposed to be the 3rd default value that's being passed in. So here's an acceptable example. We're defining this function f, integer a, integer b, integer c. The default value for c is 1. The default value for d is 1, and the default value for e is 1. This you cannot do, where you put a default value here without a default value following. So once you put a default, everything after the default must also have a default. So here's an example using a default. We're going to calculate the useful area. We'll have a width that has to be passed in. A depth, if you don't give it a depth, we'll use 200 as the default. And the easement was, well, if you don't give me an easement, we'll default that to 30. And we'll do our calculations just like normal, except if we call it with just the width, well, then the depth will be 200, and the number of easement feet will be 30. Now, if you want to add another value, you can add a depth. So we'll have width, and we'll pass a depth, because you've got a depth that's 210. But we're still using the default of 30. Now, I've got a little quick discussion on return value. That's the value is calculated, it's passed back to the caller that they're going to use in place of the function. You can think of that as the answer to the caller's question. I've got these parameters, I want to find out the useful area. What's the useful area based on these parameters? Here's the answer based on what it is. Occasionally it's not the answer, it's a success or failure. You'll very often have, you'll see something like this. You'll have status equals call some function with some list of parameters. And if status comes back 0, it worked. If it comes back -1, something happened. And if it comes back -2, -3, -4, that could be it failed for this reason. -2, it failed for this reason. You can have a long list of error codes that get returned as the return value of a function. Now, one problem, well, it may not be a problem, it's kind of a style, it's something that's picked up from C. If you define a return value, the caller is not required to use the value. So you can have a function, int, f, a parameter. The caller can just say f, and whatever return value is will just be thrown away. That's legal. It's not good practice, but it's legal. Now, there is a special type called void, which means there isn't a return. It's supposed to be called without a return value. Because basically you've got some code, you want to go and execute the code and not return any answer, because it will have some other side effect. It will write some data to a database, it will do some calculations, it will pass some data to some other process. Whatever it's doing, it does not need to return a return value, so you define it as being a void function. Now, a crucial feature that is part of object-oriented programming is you can overload your functions. Now, one thing to be careful of this is you can name a function something peculiar. Well, I can overload it, so I can use it for these 5 different functions. No, the 5 different things that you're doing should be very similar. Like add, should add a value. It shouldn't subtract anything. It shouldn't divide. You called it add, it should add. But the point being is that you can send in different types, you can send in different number of parameters. But since they are similar tasks and have different types, but they're all doing pretty much the same thing, you can use the same function name. So, for example, you have add, and you have one parameter, because you just want to add this to something. You can also have add A and B, because you need to take these 2 variables, add them together, and then add them. So these 2 functions are overloaded. And here's an example. Here is a float area that calculates an area of a square. So we pass in the size of a side, and return the side multiplied by the side. Here's one to give you the area of a rectangle. We give it one side and the other side. We multiply one times the other. And here's where the code is actually using it. So give me the side of a square. So return the area of the one, this should say side. The area side is good. And so we're calling area, we're giving it the area side. And it's whatever you put, if you put 7 in here, it will pass the 7 in here. 7 times 7 is 49. It will return 49, print that out. For rectangle, now we need 2 parameters. So ask for the first one, ask for the second one, pass that in with 2 parameters, multiply the first one times the second one, and return that. Now, one of the things about functions, it adds our modularization. Sometimes you may not even really need a function. It would be a good idea to create a function. If your code has gotten very, very long, you might well say, well, we should put this into a function, this into a function, and this into a function, and have a piece of code that calls each function. Not just divided arbitrarily, but divided in some way that makes sense. Because the modules, you make them smaller, they're easier to read, easier to understand, easier to maintain, and you will have to maintain it. Probably 80 to 90% of your programming is going to be fixing somebody else's code. So if you make it easier, then the next guy who comes in after you won't have to spend as much time figuring out what are you up to so he can fix the code or add a new feature to the code. You know, your code might be perfect, but it doesn't do everything that they want it to do. They say, well, we need to do this also, so we'll go in there and fix it. And not just thinking about other programmers. you're going to write some code this year, and you're going to need to fix it next year. Next year, you're going to have all kinds of projects under your belt. When you come back to this code, you've forgotten everything that you did. But if you make it easy to read, easy to understand, easy to maintain, you'll be able to figure out what you were thinking. So you want to isolate your modules from the enclosing system. That's because your isolated modules can be reused. If you don't have a lot of dependencies on different pieces from the rest of the application. So, okay, I've got this function. I need to know this value in the application. Well, if you really need that value, pass it in as a parameter. That way, that code can be pulled out of this application, put into another application. So, avoid using global variables. So you want to save effort when you're writing code. You would take some code that's already been written, already been tested, and you drop it into another piece of code. So you can change that code without affecting other parts of the system because it's isolated from the rest of the system. So you can do all sorts of things inside this function, inside this module. As long as it's isolated from the rest of the application, it won't affect the rest of the application. A lot of testing is you go in and you change a piece of code, you have to go make sure that didn't break something else. Happens a lot. So here we are. We're going to cut our application into many more pieces. I am taking this piece, obviously. Probably, no, I'm going to give that piece to my wife. I want this piece. It's bigger. Thank you for viewing our class today at educator.com. I will see you next time.